Okay, so here's our example problem. We want to find the area of the region bounded by the graphs of y equals x squared plus 3, y equals negative x equals 0, and x equals 1. And so the first thing that I always recommend that you do when you start a problem like this, when you want to calculate the area between two curves, is to graph all of your equations. Right, so let's draw our coordinate plane. I'll start by drawing the y-axis here, and then we'll draw our x-axis, and I will label them as such. So we have the x-axis here, the y-axis here, and now we are ready to graph our functions. And so let's start with y equals x squared plus 3. We know that an x squared function is a parabola where the vertex is at the origin, but since we have this plus 3 here, that means that the parabola will be shifted up 3 units in the y direction. And so if we say that this line right here is y equals 3, then our parabola, or x squared plus 3, will look something like this. Okay, so that's going to be y equals x squared plus 3. And then let's graph y equals negative x. We know that y equals x is just a line with a slope of 1 that crosses through the origin, and so negative x would be the reflection of that line, or it would be a line crossing through the origin with a slope of negative 1. And so that line will look something like this. All right, so that is the line y equals negative x. And so then we have x equals 0. That's actually the same as the y-axis, right? When x equals 0, that would be this line right here. So we don't really need to draw that line, but we have another line, x equals 1, that we should draw on our graph. And so if I say that right here is x equals 1, then our line for x equals 1 would look like this. All right, so that would be the line x equals 1. And so now we can see that the region that is bounded by these graphs is this shape right in here. Okay, so I'm going to shade in this region. This is the region that we are looking to calculate the area of that lies between two curves, right? It is between y equals x squared plus 3 and y equals negative x. X equals 0 and x equals 1 are simply just our bounds of integration, right? This shaded region lies between x equals 0 and x equals 1. And so if we want to calculate the area, let's set up our definite integral. We'll have that the area is equal to the integral from a to b of f of x minus g of x times dx. Now, before we can set this up, we need to determine which is the top function and which is the bottom function, right? Which is f of x and which is g of x. And so in this case, if we're looking at our region and you look from the top down, since we are integrating with respect to x, you want to look from the top down, we can see that the top function is y equals x squared plus 3, and the bottom function is y equals negative x, right? This line is the bottom of our shaded region, and this parabola, or this function, is the top function of this region. And so this is f of x, and this is g of x. All right, so our area will be equal to the integral from a to b, which in this case will be from x equals 0 to x equals 1. So we will go from 0 to 1 of the top function, x squared plus 3, minus the bottom function, which is negative x. And so we'll have negative x, and then we will write dx. All right, and so now all there's left to do is to simplify and solve this definite integral, and we will have the area of this shaded region. And so if we simplify, this will be equal to the integral from 0 to 1 of x squared plus 3, and then this negative and this negative will cancel out to become positive, so we'll have plus x and then dx. All right, so now we can integrate all of these terms by using the power rule of integration, and so we'll have that this is equal to the integral of x squared, and remember that the power rule of integration says that we add 1 to the exponent and then divide by that new exponent, and so we will have x to the third power divided by 3 plus the integral of 3, and the integral of any constant is just that constant times the variable of integration. And in this case, we are integrating with respect to x, that's what dx tells us, and so we will have 3 times x. And then we can use the power rule on our last term, which is x. And so if we add 1 to the exponent and divide by that new exponent, we will have plus x squared divided by 2. And that will be evaluated from 0 to 1. All right, and so if we clean up our work here, we can evaluate this to find our area. And so we'll plug 1 into this expression and then subtract plugging in 0 into this expression. And so if we plug in 1, this will be equal to 1 cubed divided by 3 plus 3 times 1 plus 1 squared divided by 2, and then we're done plugging in 1, right? I just replaced each of these x's with 1, and so that's how we got this expression right here. Now, we want to subtract plugging 0 into this expression, but note that plugging 0 where x is just going to result in 0 everywhere, right? 0 cubed divided by 3 is 0. 3 times 0 is 0. 0 squared divided by 2 is 0. So really, we're just going to be subtracting 0, and so that's not going to affect the rest of this calculation. All right, and so if we simplify what we have here, this will be equal to 1/3 plus 3 plus 1/2. Now, 1/3 plus 1/2 is equal to 5/6, so this will be equal to 5/6 plus 3, and 3 could be rewritten to be 18/6, so we'll have 18/6. And so if we add 5 and 18, since we have a common denominator, this will be equal to 23/6. And so that is the area of this shaded region between these two functions.